Friends, welcome again into my today's session of mathematics into my YouTube channel Maths with Mukesh Raj. Today, once again, we are continuing our discussion on height and distance, that is application of trigonometry into part 5, where we will be dealing with problems. That means questions that may enhance our skill to apply the three cases that we have already discussed into my previous video, and I had already discussed one of the questions related to the first case, and continuing with that same first case, today we will be discussing another question. So friends, it is a request, if you have not subscribed my channel Maths with Mukesh Raj, please do not forget to subscribe my channel. And if you had already subscribed my channel, then please do not forget to subscribe it from multiple devices, because that motivates me to come in front of you and have a discussion onto my grabbed knowledge so far. Friends, let us not waste time and dive into this world of application of trigonometry with the problems. So the problem again, this problem is again belongs to the first case of the application of a trigonometric ratio, where we would be directly given either the angle of elevation or the angle of depression, and based on that given fact we would be able to solve the problem. So let us first read out the question and see how we can solve this and how it is related to the first case. The question says that the length of a ladder is given as 15 meters, and which is touching the top of the vertical wall. That means the ladder is being made standing against the wall, and we know that a wall always makes 90 degree with its floor, and then we are putting this ladder onto this somehow like this. Okay, so at the back end here there is a wall, and the ladder is kept slanting on the wall from the at a particular distance from the foot of the wall, that is the floor, or that is on the floor. Now here it again asks to calculate the height of the wall onto which the angle of, not exactly the angle of elevation, but an angle of 60 degree is made at the top of the wall where the ladder is being touching the wall. Okay, so with this, as we have already discussed, as I had told you in the previous session, that to solve any of the problems or such problems in trigonometry, you will have to first try and depict the entire problem in the form of a picture or graph diagram. So I'm just trying to depict it in the diagrammatic form. So this is how it is being depicted. Suppose that this is the ladder. Okay, just to differentiate it from the usual drawing of the floor and the wall, I'm just trying to make this in the form of a ladder. So this one is the ladder, which is being kept slanting on the wall in such a way that it makes an angle of 60 degree over here. The ladder makes 60 degree with the wall, and as it is said that the ladder is 15 meters, so the length of the ladder is given. Let us write down this on the figure itself, 15 meters. Again, the next step is to give the nomenclature or point out the points with some representation, so it becomes easy to identify the things. Let us assume that the top of the top of the wall is marked as point A, the bottom of the wall is marked as B, and the point where the ladder touches the floor is the point C. Now, again, the question asks us to find out the height of the wall H. So now, how can we find out? Because the angle of elevation is not given directly to us. So in that case, from the angle sum property or the angle sum property of the triangle, we can find the angle C, and without much calculation, I will let you know angle C, which is equal to the angle of elevation okay. So angle C is the angle of elevation, which will be equal to 30 degree. And how can we get it? We can get it directly by using the angle sum property of the triangle. Angle sum property. angle sum property of a triangle, which is equal to 180 degrees. With this, we can move ahead. Now we have got the angle of elevation. Now directly we can apply it. But here it is not required that all the time you will have to use the tan value. Why? Because tan is used with the opposite and the adjacent. So we can, if you want, and if you want to increase the number of steps, we can use it. So then in that case, what we have to do, we have to be more calculative. So rather than using that tan 30 or any other, what would be the probable trigonometric ratio that we can use and get the result? So either you can use cos 60 or we can use the sine 30 value. Okay, cos 60 or sine 30, that would be helpful for us to find out the value. So in this right angle triangle, I'm going to use it with the help of so let us use this cos 60. Either you use this as cos 30 sine 30 or cos 60. So let us see cos 60. I'm using here is cos 60 degree, which is equal to the adjacent upon hypotenuse. So I will be using here directly AB upon AC. Fine. So cos 60 is none other than half. So we can write here cos 60 as half is equal to AB is the height. So I need to calculate the height, and AC is 15. Now with this, we just cross multiply each other and see what is the difference that we are getting. So I can write H is equal to 15 upon 2, that is equal to 17, sorry 7.5, oh sorry 7.5 meters. So this is how we can calculate the value. So these are the first case implementations are very easy, or we can even get it done by the help of sine 30 value. So who can tell me how we can apply it? Sine 30, this is the second method. Sine 30 would be equal to so friends, that is all from my end for this session. Hope this would have helped you to get the concepts clarified a bit more, and this will again help you to solve problems related to application of trigonometry in the height and distance section. So friends, see you very soon into the next video. So please do not forget to like, share and subscribe my channel if it worth you and your friends, your family. So friends, very soon see you. Take care. Bye bye. See you very soon into the next video. Thank you so much, friends.